For this lesson, we're going to talk about complex area. The objective of today's lesson is to be able to solve area problems that involve more than one shape. Some background knowledge you have to know in order to do these types of problems would be knowing your area formulas. Lucky for us, those are given to us on the formula sheet. Now, the three ones you're really going to have to dive into is rectangle, triangle, and circle. So to start off with, we're going to do a quick review of those area formulas and how you work with them. Something else you need to understand is that when you have two areas attached to each other, you're going to be adding their areas. When you have an area within an area, that is a subtraction type problem. This will make a lot more sense once we actually get into our practice problems. So first off, let's talk about a rectangle. A rectangle has two types of measurements that deal with it. Its length and its width. Now, for area purposes, you simply multiply those two together. Area is equal to length times width. So let's assume the length maybe is 5 and the width is 2. To find the area of that, you simply multiply those two together. So if we multiply 5 feet times 2 feet, our ultimate answer is 10 feet squared. Important to note is area always has squared units. Let's talk about our next shape in question. If you just look at the blue outline, you're looking at a rectangle. Well, if you were to cut that rectangle in half by putting a diagonal through it, you essentially create two triangles. Now, what that boils down to is it takes two triangles to create one rectangle. Now, if we look at the area formulas, the area formula for a rectangle is area is equal to length times width. If you look at the area formula for a triangle, area equals 1/2 times base times height. These should look very similar to you. There's two unknowns for the rectangle, the length and the width. There's two measurements in question. There's also two unknowns or two measurements in question for the triangle. That is the base and the height. The only thing that's different between the two is this 1/2. So where does that 1/2 come from? It comes from the fact that a triangle, looking at this, is half the area of a rectangle. Now, if you're looking at this type of triangle, you may be thinking, how is that triangle half the area of a rectangle? Well, what it essentially boils down to is this piece right here is half of the area of the rectangle. Well, where does the other half of the rectangle come in? If you were to put these two pieces right here together and add up their areas, that would give you the other half of the rectangle. So now let's actually do some area work with a triangle. Now, before we did talk about a rectangle and how it had length and width, and I've already showed you how that is similar to find the area of a triangle. We have length and width for the rectangle, base and height for a triangle. Now, lucky for us, in this case, we're looking at a right triangle, which means the base and height, which are the two measurements that deal with the triangle, are very obvious in this situation. Our base is considered the bottom, like the base of something. And the height, of course, is how tall this is. Well, you look at the lowest point to the highest point when you look at a triangle. In this case, it's just from here to here. So it's fairly obvious. So in this case, let's pretend the base is 10 inches and the height is 8 inches. So we're going to have to use the area formula for a triangle, which is area is equal to 1/2 times base times height. Again, when we found the area of a rectangle, it was length times width. We still kind of have those two measurements, just now we call them base and height when we deal with a triangle. And remember how a triangle is half the area of a rectangle? That's where this 1/2 comes in. So now you need to plug in your B, which is 10 inches, and your H, which is 8 inches. So B gets replaced with 10, and H gets replaced with 8. Now, you could just go on and multiply them straight across, or you can say 10 times 8 is 80. And then again, a triangle is half the area of a rectangle, so you can simply cut 80 in half, which is the same thing as multiplying by 1/2. They're the same thing. So the ultimate area is 40. And since we're dealing with area, the unit, which in this case is inches, should be squared. Let's go on and move on to another type of triangle. In this case, we just have a normal triangle. The last one was a right triangle. And why was it a right triangle again? Because there was a right angle. But it was really obvious that there was a base and a height. When you look at this one, you have to do a little bit more work. There was still a bottom of this triangle, so we still have a base, which is down here. But now we have to work a little harder to find the height. As I said before, the height of a triangle is the lowest point to the highest point. Well, what is the highest point on this triangle? Right here. And the lowest point is any place down here. But it needs to be an exact height from top to bottom. If you're measuring the height of yourself, you wouldn't measure from your shoulder to your left foot. You'd measure from the top of your head to the bottom of your foot. Same situation here. So you have to go straight down. So this would be considered the height. So let's go on and throw some numbers into this and actually find the area. So let's pretend the base is 12 meters and the height is 6 meters. Now you're still going to do 1/2 times base times height. And you're still going to plug in your base and your height. So that would be 12 for B, 6 for H. Now again, you could multiply these straight across, but I feel like the easier way of doing it is to go on and just multiply your base and height and then cut it in half, which again is what timesing by 1/2 actually does. And what is 1/2 of 72? 36. We're measuring in meters, we're dealing with area, therefore it will be meters squared. Now the fun part, circles. There are two measurements that you have to understand in order to find the area of a circle. The first one is called the diameter. The diameter is a line that goes straight through the center of a circle from one side of the circle to the other. Now it's important to note that it doesn't always look pretty or clean like this. It could be from here to here. It could be something like this, just straight down. The only thing you have to pay attention to is that it goes from one side of the circle to the other, but also cuts through the middle. The other measurement you have to understand when it comes to finding the area of a circle is the radius. And simply put, the radius is just a measurement from the outside of the circle to the center. It could look something similar to this, or even this. Now, if you're noticing a relationship between diameter and radius, you're correct. Diameter goes all the way through a circle, through the center, and radius goes to the center. So with that being said, we should understand that the radius is actually half the diameter, and vice versa. The diameter is twice the radius. Now let's actually find the area of a circle. Now to find the area of a circle, you have to know what the formula is. Lucky for us, those are given to us on the formula sheet. And it looks like this. Now, the R in this situation represents radius. Now, I did mention to you all that the diameter is also an important measurement when finding the area of a circle, and that is correct. It's just not actually used in the area formula. But they could possibly give you the diameter and want you to find the area. So how do you go about doing that? Well, the diameter is a measurement that goes straight through a circle through the center, and radius is half of that. So if they were to give you the diameter, let's say 8 centimeters, you'd have to cut that in half first to get your radius. And then you would know what to plug into your area formula. Now let's talk about the other piece of this area formula, which is pi. Pi can be approximated to 3.14. It's important to know that that is not an exact number for pi, but it is okay to plug that number in for pi whenever you see it. Let's actually find this area of this circle now. Remember, pi is 3.14, and in this case, the radius is 4 centimeters. Area is equal to pi times radius squared. Diameter is 8, radius is 4, again because it's half of that. First, let's plug in our radius. It's 4, therefore it's 4 squared. Pi, 3.14. What is 4 squared? 16. And what is 16 times 3.14? 50.24. Now again, since this is area, we take the units and then we square them. So all this stuff is great to know, but what exactly will you be seeing on the HiSET test? You could see something similar to this. Consider the diagram below, and they give you a diagram of a dollhouse and a deck. And then the actual question asks, what is the combined area of the dollhouse and the deck? This is simply asking you to find the area of the total shape, which in this case is a rectangle and a triangle put together. When you have two shapes attached to each other, you find the area of both and you add them together. So now we just need to find the area of the dollhouse and the area of the deck and put those two things together. So the dollhouse is shaped like a rectangle, which means it has length and width. And how do you find the area of a rectangle? Length times width. In this case, that is 12 times 5, which is 60 inches squared. So the area of this rectangle, 60 inches squared. The only tricky part about this triangle over here is understanding what its height is. Well, if we have 5 inches over here, that is the same as 5 inches on this side. So now we know the height of this triangle, which again is bottom to top, is 5 inches and the base is 4. The area of a triangle is equal to 1/2 times base times height. So that is 1/2 times 4 times 5. What is 4 times 5? 20. What is half of 20? 10. So we have 10 inches squared for the area of the deck, which is a triangle. Now that we know the area of the rectangle and the area of the triangle, again, the question is asking for the combined area. That means add them together. When you combine things, what do? You add them together. What is 60 plus 10? 70 inches squared. Now, that does mean that C is the correct answer. But where in the world did some of these come from? To start off with A, we have 50 inches squared. Where could that number have come from? Well, we know it's saying combined area, which means we should add them together. Well, if you had accidentally subtracted them, what is 60 minus 10? 50. So that's where the incorrect answer of A comes from. What about B? Well, if you had taken this figure and tried to incorrectly add all the sides together, you would have ended up with a number that was very close to 38. Now, what about 240? Because you know that area usually uses multiplication. So this trick answer of D is assuming you're just going to multiply all the numbers together. So if you had done 5 times 12 times 4, you would have ended up with 240. So we just did a problem where you had to add the areas together. There are situations on the HiSET where you would have to subtract the areas. For example, this question. The following is a diagram of a swimming pool area of a dollhouse which includes the pool and surrounding tile. What is the expression for the area of the tile? This one is slightly different than what we just did. We actually found an answer. This one wants us to find the expression for it. So what does that exactly mean? It means it wants you to write out how you would do it. So first off, we need to find the total area of the outside. Well, what is the shape of the outside? A rectangle. How do you find the area of a rectangle? Length times width. That would be 15 times 6. Now this is an important part. When you're setting up an expression, you shouldn't solve anything. So instead of saying 15 times 6 and then putting down your answer, leave it 15 times 6. So the area of a rectangle in this situation is 15 times 6 and just leave it. So now we need to find the area of the inside shape, which in this case is a circle. And how do you find the area of a circle? Pi r squared. And looking at this one, our diameter would have been all the way through, but our radius is halfway through. So luckily they gave us the radius, which is 3. So going back to our formula, it should be pi times 3 squared. Again, radius is squared, radius is 3, so therefore it's 3 squared. Back to the problem. This is an area within an area. When that happens, you use subtraction. So what you should do is subtract the inside piece from the outside piece. Well, our inside piece is pi times 3 squared, and our outside piece is 15 times 6. Well, since we have an area within area, again, we're going to subtract. So let's put the outside piece, which is 15 times 6, and then let's subtract the inside piece, which is pi times 3 squared. So this is an example of one of the expressions you could see as an answer choice for finding the area of the surrounding tile, which if you remember in the question, we were solving for just this part right here. This is the surrounding tile. Now, while this may be an answer choice, you may also see something slightly different. Now, what is 3 squared? 9. And what happens when you have a number and a variable? You smash them together. So while pi times 3 squared is correct, you could go on and extend it into 9 pi. So let's review what we've talked about today. We talked about how to find the area of the shapes you'll be seeing on the HiSET test, which was the rectangle, triangle, and circle. Then we talked about the types of problems you would actually see on the HiSET test, which involved having two shapes together, which is when you add their areas, and when you have a shape inside a shape, which is when you subtract their areas.